Ever wondered what does selecting the default all interfaces option in the host section of the HTTP listener config does? Is it a good practice? Can it pose a security risk? Well, if you have the same questions, this video will help you understand this trivial yet impactful property of the HTTP listener config. Let's get started. First of all, let's understand what is a network interface. Any server will have physical or virtual port for communication. These ports are called as interfaces. For example, the server here has three different interfaces: Ethernet 1, Ethernet 2, and wireless. It means that this server can simultaneously connect to three different networks using these interfaces. Assume there is a network 192.168.0.0 with a CIDR notation of 24, another network 10.0.0.0 with a CIDR notation of 24, and a third network 172.16.0.0 with a CIDR notation of 24. The server is connected to all the three networks using Ethernet 1, Ethernet 2, and the wireless interface. When it connects to these networks, it gets an IP address in that network and becomes a part of it. Apart from these three interfaces that we discussed, there is yet another interface, and it is called as the loopback interface. The network 127.0.0.0 with a CIDR notation of 8 represents the loopback interface. Any request to the IP address within the loopback range will hit the host itself. Now coming to our HTTP listener config. If we deploy a mule application with HTTP listener having config that listens on all interfaces of the server, it would mean that the mule app will be accessible on the interface Ethernet 1 using the IP address 192.168.0.4, Ethernet 2 using IP address 10.0.0.4, and wireless using the IP address 172.16.0.4, and finally the loopback using IP address within 127.0.0 with a CIDR notation of 8. Since the mule app is accessible on all the interface of our server, any device in the network that our server is connected to can access the mule app. In certain cases, such an access is not desired. The very next question that you might have is why such an access is not desired. Assume that this server hosts HR, IT, and operations apps owned by the respective departments. The requirement here is that the applications should be accessible only within the department's network for security reasons. So if the applications listen on all interfaces, even with different ports like 8080, 8081, and 8082, they would still be accessible by members from other departments. Like HR can access IT apps, IT can access HR apps, and so on. For time being, assume that these are dashboard apps and they don't have any credential based access. Anyone in the network can simply access it. Take another example. There could be a web service that helps manage the web server and should be accessible only by someone who is logged into this web server. So if it listens on all interface, the management web service can also be accessed by the users from other network or departments. Worst case, if the server is an EC2 instance having internet access and firewall rules configured in such a way that it accepts incoming connections on port 8080, 8081, and 8082, then these services can be accessed by anyone on the internet. Everything that we discussed so far poses a security threat to the application. So what should we do to restrict the access? Well, you should not select the all interfaces options in such case. Instead, enter the IP address of the server on the network that you wish to access it. For example, if you want HR apps to be accessible on the HR network, enter the host as 192.168.0.4 because this is the IP assigned in the HR network. Similarly, 10.0.4 for IT, 172.16.0.4 for operations, and for the web server management application, which needs the access only on the same server, you can select localhost, which is the default option. So when you select localhost, it will listen only on IP 127.0.0.1, which is part of the loopback interface. Now take this information with a pinch of salt. This configuration of not listening on all interfaces will work only on hybrid deployments where you have a standalone runtime. For CloudHub 1, 2 and RTF, it should always be all interface due to the internal architecture of this infrastructure. We'll try to understand it in detail in the next slide. So in case of CloudHub 1.0, the Mule application can be accessed in three different ways. The first is through the load balancer. It could be shared or dedicated. The second one is through the Mule worker URL, which exposes the Mule application on a public IP address. And the third one is the Mule worker internal URL, which exposes the Mule application to a private IP address. So if we translate these three methods of accessing in terms of interfaces, we will have two interface. One is the public IP URL and the other one is the private IP URL. The third one is not required because the load balancer is a different component altogether, and this load balancer internally uses mule worker internal URL to provide access to the mule app to the external world. So we have two different interfaces. But if you check in reality, it's just one interface, which is this private IP address. The mule worker gets a private IP address on its actual interface, and the other one, which is public IP address, is part of the internet gateway. An internet gateway is attached to a VPC, and that public IP address gets translated to the private IP address. So reality, there is only single interface, but for the sake of understanding, I've created two different interface. So now, in case of the HTTP listener config, in host, if you do not select all interfaces option and you select, for example, localhost. So in that case, what would happen is you won't be able to access the Mule app through these three different mechanisms, which are the default mechanism. There's no way to access because you selected the host as localhost. When you select localhost, it means that this host will take a value of 127.0.0.1, which is the loop back IP address. So what does it mean? It means that if someone wants to access the Mule application, he has to log into this Mule worker and only then he can access because the loopback address hits the same machine, right? So someone has to log in and only then he can access that Mule application. So this defeats the whole purpose of accessing the Mule application, right? Which is not, it's not possible on CloudHub. You can never log in to the mule worker and gain access. So it just defeats the whole purpose of your API. So you cannot have local host. You always need to have all interface. But even then, if you want to have something in host, right, you cannot add any value because first of all, you would think that you can add a private IP address, but that's not possible because private IP address, you do not know which IP it would get assigned. It's all dynamic. You do not have control of a private IP address. The whole purpose of selecting a host, particular host value is that you need to restrict the access from different network. So if we go back to the previous slide, right? In that case, this server was on premise and this server was connected to three different private networks. So in this case, it is connected to 192.168.0.0. Other one is 10.0.0 and the third one is 172.16.0.0. So one single machine interfaced to three different private networks, and any of them, if it was exposed on all interfaces, any of the network person can access it from any network. So that was the problem. But in case of CloudHub, it's different altogether. This machine has only one interface Although I have shown two, it has only one interface and it's connected to only single network. It's not connected to multiple network. So this is the only this private IP address you see. It could be either from your dedicated VPC that you created or the public VPC that CloudHub already provides you. So it's only part of a single network. It's not shared across multiple network. So in this case, you can safely use all interfaces. And also, since we want to expose right by the architecture of the cloud app, always we need to have this three access working, right? So in that, to serve that purpose also, you need to have this host section as all interface. Now, even if you still want to restrict access, right, in that case, you can create your own VPC and then add firewall rules to it, that which network you want these apps to access. For example, you have a VPC which is connected to your on-premise network, and since there is a tunnel, the other person from the VPC can always access your mule application, right? So if you want to block access to certain network on premise, then you can just add a CIDR block to the firewall rule and specify the rules that okay, this CIDR block cannot access a mule application, cannot access the VPC altogether, so it won't be able to access the mule app. So that is the way you can move to restrict the access. But when on CloudHub 1.0, always remember the host should be set as all interface. Never change this value, or else you would run into access issues. Same is the case with CloudHub 2.0. Now, CloudHub 2.0 is a containerized platform, and so is RTF. So, in this case, a Mule app is containerized, and then the container is wrapped inside a pod, and they have their own networking, right? So, in case here, if you want to select the host and provide certain IP address, that's simply not possible because you don't know what IP address would be assigned to that particular pod, right? And also there are multiple ways in which the Mule application can be accessed in CloudHub. One is through the ingress, the other one is through the cluster IP service, and all of these IP addresses are dynamic in nature. So you can never put in an IP address in the host section. If it is done, then in that case you won't be able to access the Mule application. So even in case of CloudHub 2.0 and RTF, never change the host from all interfaces to any other value. Now it's time to validate our understanding using a practical demo. So for the demo purpose, I have set up two networks. The first network is 192.168.29.0 with a CIDR notation of 24. It's hosted by a router having SSID as WLAN 2.4 GHz. We have another network with a CIDR notation of 192.24 on the network 192.168.0.0, and it's hosted by a router having SSID as DLink. SSID means service set identifier, the name using which the router will broadcast itself. So this particular laptop, uh, which will host a Mule application, is connected to both the network. So it's connected to the D-Link network using the Ethernet port, and it's connected to the WLAN 2.4 GHz network using a wireless interface. And both the network will provide it an IP address from it. So on the WLAN 2.4 GHz network, it has an IP address of 192.168.29.61, whereas from the D-Link network, it has 192.168.0.51. So these are the two IP address. Now, what I'll do is I'll use a mobile phone, connect it first to the D-Link network, and try to access the Mule application on this IP address, and then move it to the other network and test the connectivity or to the Mule application from this network. So when I'll connect this mobile device to the D-Link network, I'll try to access it on this IP address, which is 192.168.0.51. And when I move it to the other network, I will test on this IP address to prove the fact that both the devices in both the networks can access the same application since it is listening on all the interfaces, right? So to demonstrate that, I have created a mule application. It's a very basic app having an HTTP listener and a transform message, which will just return a message hello world and print all the attributes present in the request. And right now, the listener is listening on all the interfaces. So yes, here is the message. So it's printing the messages hello world and the attributes that are coming from the request. And in the listener, if we go to the configuration, it's listening on all interfaces. Now, this is the same laptop which is going to host the Mule application. So it is connected to two different network. If I show the network tab, you can see. So this D-Link is connected using Ethernet and WLAN 2.4 gigahertz is connected using Wi-Fi. If I show the IP config, here you can see the Ethernet adapter. It's showing as Ethernet 2, and this is the IP address that's being assigned 192.168.0.51, and same is shown in this diagram. And the next one that you see here is the IPv4 address for the Wi-Fi, uh, which is the WLAN 2.4 gigahertz network, and the IP address is 192.168.29.61. So this is 192.168.29.61, and the respective gateways can also be seen here. So this is the gateway for D-Link, and this is the gateway for the WLAN 2.4 gigahertz network. So since the app is already deployed, we can start the demo. Before testing it on a mobile device, we will also test on the same machine using the loopback interface. So we know that the interface with a CIDR block of 16 on the network 127.0.0 is will hit the same machine. So since the application is listening on all interfaces, right? So it should work on the loopback address as well. So if we type in 127.0.0.0, it should be 1. So it should return the response. So it is returning us the response. And we see that the remote address and the local address are same. Now any address within this range will work. So if I make it as 1, even this works. See the IP changes. The local address is this and the remote address is this. So it works on any address of this range. So here it's the local address is changing accordingly. And obviously, this two addresses also will be accessible because it's the same machine and having both the IP address. So if even if I paste this, I should be able to get the response. So you see, I'm getting the response. Now, since it is the same machine, local address and remote address are showing the same address. The only thing that changes is port. The local address is obviously listening on port 8081, and the requesting port, which is opened by this Google Chrome browser, is this 57611. So this IP address is from the WLAN 2.4 gigahertz network. Now, if I use this D-Link network, this also will work because it's in the same. I'm trying to hit the same machine, right? So it should work. And you see it's working. The IP address is same. The only thing is that the port changes. Now, now the real testing will come when I test it using the mobile device. So in the next test, I am going to connect this mobile device to this D-Link network and then try to access this particular IP address. So now let's connect to the SSID D-Link. I'll enable the Wi-Fi. I'll search for networks and I'll connect to this one, D-Link. Once I connect, I'll get an IP address
If you check the IP, it's 192.168.0.52. This is the same that was shown in the diagram. Now let's go to the browser and enter the URL. So this is the IP address on which the Mule app is hosted on this particular network. So I'll hit enter and I get a response. So if you check the local address value is 192.168.0.51, listening on port 8081. So this is the IP address on which the Mule application is listening, and here is the remote address. It's 192.168.0.52 and sending a request from port 42180. So this is the IP address of this mobile phone on the SSID D-Link.
Now we'll switch over the network on this mobile device to WLAN 2.4 gigahertz. So let me move this to this network, and the IP address will change. It will become 29.131. Remember, the Mule app is still listening on all interface, which means that even any device, even in this network, should be able to access the Mule app using the IP address from this network. So what I mean to say that this mobile device can still access the Mule app using this address 192.168.29.61 because this laptop is part of the 2.4 gigahertz network as well.
Now let's switch over to the other network. So I'll again go to Wi-Fi and select the SSID WLAN 2.4 gigahertz. So here is the one. I'll connect to it. Let's go back to the browser. Now since we have changed the network, right, we need to test it on other IP. So the IP address that we saw was 192.168.29.61. So I'll enter that ID 29.61 and I'll hit enter. So now the response changes. If you see the local host, the local address is now 192.168.29.61 listening on port 8081, and the remote address is 192.168.29.131, which is the IP address of this mobile device in the network with SSID WLAN 2.4 gigahertz. So we were able to access the Mule application on two different interfaces. One was the Wi-Fi interface, which was on SSID D-Link. Uh, Sorry, the Wi-Fi interface is WLAN 2.4 gigahertz, and the other one was the Ethernet interface, which was on the SSID D-Link. So we were able to access on both the interfaces.
So we have successfully validated that when the Mule app listens on all interfaces, it is accessible from all the networks it is connected to based on the IP address that it has on that particular network. We also saw that it's also accessible on any IP address from the loopback CIDR block. So we were able to access it on 127.0.0.0 on CIDR notation of 8. It worked on any IP. Now, what we will do is we'll change the all interface option. We'll make it as localhost only. So let's go to the Mule app, edit the configuration, and change it from all interface to localhost. So when I make it as localhost, it should be accessible only on this device. It won't be accessible from devices on any other network which this laptop is connected to. What I mean to say is none of the devices from this network or this network will be able to connect on this IP addresses which is being given by this networks. So let the app get redeployed. So it's redeploying. Okay, so it's redeployed. Now the application will only be accessible on local host. So if I try to refresh this, right, it won't work. It will give error. See, it says that it can't be reached because it's refusing to connect. Let's also try the other one, which was 29 dot, what was the IP address? It was 61. So let's make it a 61. And it gives the same response, refuse to connect. Now it will work on localhost, and localhost is 127.0.0.1. So it should work here. So it's working. Now remember, when you select localhost, right, it means that it will only work on 127.0.0.1 or whatever is defined in your computer's network configuration. So it won't work on the whole CIDR block. For example, if I type in 127.1.0.1, it won't work on this. See, it says refuse to connect. It will only work on localhost. So whatever is defined as localhost on your system, it will take that particular IP address. So if I say localhost, it works and it gives us this IP address. So with the localhost, it works only on the same machine. Even though it is connected to different networks and it has an IP address, the application won't accept any other connection apart from localhost. Now let's change this to a particular IP address. So I'll change the IP address and I'll use the D-Link IP address so that it's only accessible from the D-Link network. So let's go back to the Mule app, edit this configuration and change this host to this IP address. So it will now only accept connections on this particular IP address. So if you want to access on this particular IP address, you need to be part of the network which has leased out this IP address, and that network is the D-Link network. So I'll save this and give it a couple of seconds to deploy. All right, it's deploying. Now it's time to test. So I'll move this device here and it should have this IP address of 0.52 and it should be accessible only from this particular network. If you try to access from this particular network, it will give an error that it's this IP address is unreachable or it's refusing to connect.
Since the mule application is now listening on an IP address from the D-Link SSID, this page, being from the WLAN 2.4 GHz IP address, should stop working. So I'll just refresh this page and you should see that it won't be able to load any response because the app is no longer listening. So you see it's stuck, there's no response. So even if I refresh, there's nothing happening. I don't get any response whatsoever. See, it's saying site cannot be reached, took too long to respond. Now what I'll do is I'll switch over the network back to D-Link. So let's go to Wi-Fi and change the network. Takes a while to search. So here is D-Link. I'll connect to it. Let's go back to Chrome and type in the IP address. So it was 192.168.0.51. So I'll type in this address and I can see a response being returned from the Mule application. So the local address is that of the Mule app on the D-Link SSID and the remote address is that of this mobile device.
Next up, I'll try to isolate the Mule application from the D-Link network by pasting in the IP address of the WLAN 2.4 gigahertz network. So I'll move this mobile device to this network so that I can test it if it's working or not. If I try from this network, it will no longer work because I'm going to change the IP address. So once this mobile device goes to this network, the IP becomes 29.131. All right, now let me copy this IP address, which is assigned in this network, and paste it in the configuration. Let's click on edit, paste this IP address, click on OK, and save it. So once it gets deployed, we should be able to tested. Now it's only accessible from this network and not from this network.
Since the mule application is now listening on the IP address 192.168.29.61, which is part of the network with SSID WLAN 2.4 GHz, this web page has stopped working because it's trying to reach out to 192.168.0.51, which is part of the network with SSID as D-Link. So now I'll switch over to the other network and change the IP address. Let's quickly go to the Wi-Fi settings. Uh, Right now it's connected to the network with SSID D-Link. We'll go and connect to WLAN 2.4 GHz. Let's go back to the browser, edit the URL and change it to 192.168. It should be 29.61. Alright, let's hit enter and I'm able to access the web page. Here in the local address you see it's 192.168.29.61, and the remote address you can see it's 192.168.29.131, which is the IP address of this mobile device on the network with SSID WLAN 2.4 GHz.
So now it's time to summarize the learning. You should select specific interface only when you aim to deploy your Mule application on a hybrid deployment model. That is when your Mule runtime is on premise and it's connected to the control plane on any point platform. CloudHub 1.0, 2.0 and RTF should always have the host section of the HTTP listener config as 0.0.0, which means all interfaces, because of their internal architecture, and we have seen the detailed explanation in the previous slides. I haven't demonstrated this part by deploying on CloudHub or RTF because it's quite obvious based on what we have seen that it won't work, but you can test it on your own and see the results. Now, restricting interfaces can serve as an alternative for IP whitelisting policy when deployed on premise. It's because you are literally trying to block an IP, a network, right? So if you give a particular IP from a specific network, only that particular network will be able to access that mule application. All other requests would simply not be honored. And this can be done at the listener level itself. So you don't need to have an overhead of adding a policy. It goes to the policy and then comes to your mule application, right? So this can serve as an alternative. And also, you cannot add a CIDR block to the host portion. It only needs to be a single IP address. So that's all for this video. I hope you found the content useful. Thanks for watching.